Good day, viewers. Welcome to Rehoboth Glorious Heritage Academy Online Facilitation. Today we shall be looking at mathematics. We are going to take mathematics today for J.S.S 3 class. And the topic is trigonometric ratios for finding distances. Trigonometric ratios for finding distances. I believe you can still remember we treated trigonometric ratios before we went on holiday. Okay? And then we learned that we use trigonometric ratios when we are given a right-angled triangle. When we are given a right-angled triangle. That means if you are not given a right-angled triangle and you are given another shape, then you have to deduce a right-angled triangle from the given figure. Let's quickly look at some examples, and from there we shall go to other things. But before we go, don't forget I said we use trig ratios with right-angled triangle. We call it a right-angled triangle because it has this square corner. Can you see it? Okay. Now, we were taught so katoa before we went on holiday. Because these are the three basic trig ratios that we have in mathematics. We have so, we have ka, and we have toa. What does so stand for? So means sine. Ka means cosine. While toa means tangent. Tangent. So ka toa. From here, sine means the sine of a given angle is equal to O for opposite. I have to shorten it. And H for hypotenuse. Cosine, that is cos, means adjacent. That is the head that we have here, adjacent over hypotenuse. And tan means toa, opposite over adjacent. Now, how do we know which side is the opposite, which is the hypotenuse, and which is the adjacent? We must be given an angle, and the given angle will determine which side will be the opposite, which will be the adjacent. But the side that faces angle 90 degrees is always the hypotenuse, so there's no problem with that, right? So this is the side that faces angle 90 degrees. This is the angle 90 degrees, and this is the side that faces it. So that means this is the hypotenuse. If the given angle is here, this side will be the opposite, and the third side will be the adjacent. The first step that you need to take is you locate or you identify the hypotenuse. Once the hypotenuse is gotten, don't forget the hypotenuse is the side that faces angle 90 degrees, right? So the other two sides will be opposite and adjacent. Okay, which one is the opposite? The one that faces the given angle. This is the given angle now. If the angle is here, then this will be the opposite and this will be the adjacent. Did you get that? Okay. Now let's quickly look at some examples. Let's quickly look at some examples. You are going to write down the question. I will not write it on the board. You write it down yourself. A ladder 10 meters long is placed against a wall at an angle of 70 degrees to the horizontal. How high up the wall does the ladder reach? A ladder 10 meters long is placed against a vertical wall at an angle of 70 degrees to the horizontal. How high up the wall does the ladder reach? We all know that the wall should stand erect like this, and this is the ground, right? And we place the ladder on the wall. This is the foot of the ladder, and this is the top of the ladder placed against the wall. Okay, we are told that the length of the ladder is 10 meters. This is 10 meters. And the ladder makes an angle of 70 degrees with the horizontal. That means it makes angle 70 degrees with the ground. The question is, how high up the wall does the ladder reach? That means we are looking for this side. We want to know the distance between this place and the ground. That is where the top of the ladder reaches and the ground. Now look at it. Out of so, cap, and toa, which one are we going to apply? We have the side that is opposite to the given angle. We have the hypotenuse. Opposite is h. Hypotenuse is 10 meters. Which one has opposite and hypotenuse? That means we are going to use so, because so has opposite and it has hypotenuse. So we shall say sine 70 degrees is equal to opposite, that is h, over hypotenuse, and that is 10. So we cross multiply, right? We cross multiply. If you cross multiply, I've told you several times that cross multiplying means you multiply this numerator by this denominator. This denominator will also multiply this numerator, like scissors. The handle here will go with this blade, the handle here will go with this blade. Okay? H times 1 will give us h, because we know when we multiply a number by 1, we get the same number. So we have h is equal to 10 sine 70 degrees. H is equal to 10 times, what is sine 70? You can make use of your 4-figure tables, or you use your scientific calculator. Okay, from my own 4-figure tables, I have sine 70 degrees 0.9397. 0.9397. Okay, if you multiply by 10, it's going to give you 9.397. We can approximate it. So h is approximately 9.4 meters to 1 decimal place. So 1 decimal place. Did you get it? Okay. If you have any question on that, you can forward it to the platform. It will be answered next lesson. Let's quickly look at another question, and that will be the second example. Example 2. You write the question. The sides of an isosceles triangle are 6 centimeters, 8 centimeters, and 8 centimeters. The sides of an isosceles triangle are 6 centimeters, 8 centimeters, and 8 centimeters. Full stop. Calculate correct to the nearest degree the angle included between the equal sides. Calculate correct to the nearest degree the angle included between the equal sides. You know, for if a triangle is isosceles, definitely two sides must be equal, right? Two sides must be equal. So this is our isosceles triangle. This side is 8 centimeters. 8 centimeters. This is also 8 centimeters. And this is 6 centimeters. Okay, we are asked to calculate the included angle between the equal sides. The included angle, these are the two equal sides. So this is the angle connecting the two equal sides. This is the angle connecting the two equal sides. So let's call it theta. But the way it is now, it is not a right angle triangle. So how do we get a right angle triangle so that we'll be able to apply trig ratio? How do we get it? There is a law binding an isosceles triangle that states that the bisector of the vertical angle also bisects the baseline, and it meets the baseline at right angle. So that means this can be redrawn to give us this. This angle will be bisected. Then this will be theta over 2, because we have bisected it, theta over 2. Instead of 6 centimeters, this will be 3 centimeters and 3 centimeters. And don't forget, the bisector meets the baseline at a right angle. So this side is 8 centimeters. This is 8 centimeters. You can see we have two pairs of similar, we have a pair of similar triangles. This is similar to this. So we can make use of any one now. Okay? This is the given angle. Now, so this is the opposite and this is the hypotenuse, because this is the side that faces the given angle. 3 centimeters is the opposite. The side that faces angle theta over 2. Okay, so we have opposite and hypotenuse again. This is just coincidental. It doesn't mean every time you must use sine. You can use any of the three. That is the ones that you are given. We determine which one you will use. Okay, so we have sine theta over 2 is equal to opposite. That's 3 over 8. 3 over 8. So sine theta over 2 is equal to, what is 3 over 8? We make use of a calculator. 3 over 8. We change it to decimal form. 3 over 8. 3 over 8. That's 3 divided by 8. And that is 0.375. 0.375. Okay? The sine of a given angle gives us 0.375. What do we do to get the given angle? We are going to say theta over 2 is equal to arc sine 0.375. That means theta over 2 will be equal to. Now let's take our formula. It's either you use the formula tables or you use your scientific calculator. If you are going to use your scientific calculator, you press shift sine 0.375, and that is 22.02. If you make use of the four figure tables, you go to sine. Where can you get 0.375? Which angle will give you 0.375? You will discover that it is 22 under 0 difference 2. 22 under 0 difference 2. 22 under 0 difference 2. So this is 22.02 degrees. But we need theta. So theta will be equal to 22.02 degrees times 2. Theta is equal to 44.04 degrees. Approximately, theta is equal to 44 degrees to the nearest degree. Did you get it? I believe you listened attentively. If there are questions, you can forward your questions to the platform and it will be answered. So I'm going to give you classwork now. We are using our textbook, Macmillan Progressive Mathematics for J.S.S 3. Go to pages 117 and 118. Pages 117 and 118. You will answer questions 1 and 2. So in a few minutes time, I will come up again. Then we'll do correction. And if you have questions, don't hesitate to ask. If you have questions, don't hesitate to ask. Thank you.